Hello, welcome back to RC Video Reviews. Tonight we're taking a look at the Flite Test Radial 2218 1180 kV. I got this motor from one of my squadron mates, John, who's also a subscriber to the channel, and he brought it over and asked me if I'd put it on the bench to take a look at it, and I said sure. The thing is though that Flite Test, they don't list the amperage. So since they don't list the amperage, I got out a 16 by, what is that? I don't know, 16 by 12, 16 by 12 prop, and a 5S pack, and I'm going to beat the out of this thing. All right, I'm just kidding. I was just trying to get John worked up a little bit. I was kind of seeing if I could get him to have a stroke with this 16-inch prop and a 6-cell battery. We're not going to do that. While I have the greatest amount of respect for Flite Test, I really don't think it's cool to sell motors and not list the maximum amperage on a motor. That to me is the cardinal sin. You have to know what it is so you know how to spec these. I'm going to show you how to do it anyway, but you kind of need to list that. Here's what they say. They talk a lot about the magnets. They talk a lot about this special cooling feature with their fins, and that's all good stuff, but I want to get to the meat of it. How hard can I spin this thing? And the only thing they say is that you can use a 10 by 4.7 prop on 3S and 4S, and that's a slow fly prop, by the way, and they say the input voltage is 3S to 4S. Number one, I don't care about input voltage. I want to know what the maximum amperage is on the motor, because that's what generates heat and that's what causes failures on these things. The voltage, the wires don't care. But we're gonna get to the bottom of this, okay? We're gonna figure it out. So what do we do if we don't have the right kind of prop test data or maximum amperage guidance for motor? There's two things that we can do. Number one, we can look at other motors in the same class. So this motor is listed as a 76 gram motor, and before I came out to do the test, I went and found a couple of other motors in the same class. I found a Leopard 2835 1160, that's a 71 gram motor. I found a Rimfire 10, that's a 71 gram motor. I found a Cobra 2217, that's a 73 gram motor. All of those motors are in the same weight class as this motor. And for that reason, we can use those motors as a starting point on where we should be setting this one up. So the Leopard motor is an 1160 kV, and they say their max current is 28 amps. All right, that makes sense to me because this effectively is a 2836 class motor. And I'm gonna get to that in just a minute, but it's a 2836 class motor. All right, so they say the maximum current is 28 amps. They do not list a surge current with this one. The Rimfire 10, 71 grams, they list a max constant current of 30 amps. Okay, so we're seeing a pattern here. We got two 71 gram motors. They are 28 to 30 amps as their recommended max. Max surge current on Rimfire, this is the old standby in Rimfire, right? 35 amps. So their max constant watts, 333 watts. I expect this motor to come in somewhere around 300 watts, and I haven't even put it on the stand yet. Okay, Rimfire recommends a 10.45 to 10.7 prop. They recommend 3S, not 4S. I don't know if they say 2S or not, but I know for sure they say 3S. Now let's take a look at the Cobra. That's an 1180 kV, 73 grams, max constant current, 24 amps. It's probably just a little low. They do not list a surge current, and they don't even run a 10.47 slow fly with 3S or 4S. Now the thing about that is if you look at Cobra's prop test data, I consider them to be the gold standard in the industry in terms of publishing accurate prop test data. And if you look at their charts, they're going to show you that the max on a 3S prop is a 975. They pulled 24 amps at 264 watts. With a 10.6, 22 amps at 246 watts. And with 4S, 8.4 prop, 271 watts at 18 amps. So with that in mind, there's one other test we can use, and that's the temperature test. If you're flying a plane and you can't put your hand and hold it on that motor, and you have to take it off right away because it's too hot, it's too hot. That's too much power. It's not good to do that, because what will end up happening is you're going to soften and weaken the glue that holds the magnets to the can, and there goes your motor in flight. And it's going to happen in flight. It won't happen on the bench. It won't happen while you're playing around with it at home. It's going to happen while it's up in the air 200 yards away from you. Okay, so those are the two tests. Look at the weight and go see what other motors in the same weight class do. And then when you do your testing, put your hand on it and make sure that you can keep your hand on it for about 3 seconds. If you can't do that, it's too hot. Come on, you guys got to admit that was funny. A 16.8 prop, who laughed? I mean, I thought that was hilarious. And I hope John was, I hope John's watching and caught the joke. But 16-12 prop on that little motor, oof, that'd be really bad. That'd be severely overloaded. Okay, so here's what I'm going to look at tonight. I'm going to do a little prop tuning on this motor. I've got a 938, I've got a 947, and I've got a 1047. These are all slow fly props. So we're going to take a look at those on 3S and maybe 4S. And then I've got a 9.6, a 9.5, and a 10.6 for just a standard electric sport prop. That's where I think this motor is going to wind up. I think it's going to come in somewhere around 300 watts and somewhere around 28, 29 amps. That's my prediction. All right, let's start off with a look at the motor. As you can see, it says Flite Test Radial on there, 2218, 1180 kV, and V1. Nice little etched wing logo in there. That's kind of cool looking. I like that. The finish on the can is a very cool satin black, and it's some kind of polished cut on the base. They mentioned having some cooling fins. What do they say about this? It says, featuring unique fins machined into the bell, draw up cool air from the motor base. Apparently these are unique fins machined into the bell. I really don't know what that means, but I don't buy it. I don't see anything in there. If that's supposed to be an engineering upgrade, I don't see where it's coming from compared to other motors. I just don't see it. There's little grooves cut in the bell right there, but it's not like there's some impeller blades or anything sticking down there that make it look like this is pulling air up from the bottom like any other motor. Every other motor I've ever seen looks kind of the same. All right, as far as the windings go, they're okay. They're not the best I've seen. I think the Sunny Sky, those were definitely good looking windings. I hope that's focusing. But you can see if you look real close, like there you go. Right there, there's some windings that are just kind of hopping. They skip. So these are probably machine wound. It's not the best job on the windings I've ever seen. The silicone boot looks like it's fed in there really nice. And this is interesting. They've got some kind of Torx bit on the bottom of the motor right there. No E-clip. That's not bad. I kind of makes me think that it's threaded on the bottom, and if you want to pull the can off, you just pull that thing out. I don't dislike that. That's actually pretty cool. On the other hand, though, look at that. That prop shaft is hollow. Don't crash this. If you're a crasher, this is not a good motor, I can tell you right now. Because here's another thing. That's part of the bell. You can't replace that. Just like a normal shaft, I don't see... I'm not going to pull it apart because it's not my motor, but I don't see any grub screws on the side, which tells me that it's got to be pressed in. See, normally you'd see some grub screws right inside one of those spots right there, and that's what normally pinches the bell onto a shaft, and I don't see anything in there. So that leads me to believe that's either press fit or it's part of the bell itself. I'm not sure. I don't know. And again, I'm not going to pull it apart because it's not my motor. So I don't know how I feel about that. That looks to me like a weak point. I prefer a solid shaft, and as you guys know, I don't like these proprietary setups anyway. I prefer something that lets me put a compression fitting on, put my prop on. If I prang something, I can pop that compression fitting off, stick another one on, and I'm back in business. Or if I bend the shaft, I can pull it out and put another shaft in, and I'm back in business. So I don't know, not a fan of that, to be honest. All right, other than that, everything else looks like it's high quality. I'll know more when I put it on the judge in terms of how it sounds. There's no longitudinal play in there at all. It's very, very snug. So yeah, overall, I'd say it looks pretty good. I'm not a big fan of that. That's a big hole, and to me, that weakens the shaft, and I don't really care for that. So anyway, now I got to put this thing together. Oh, screws. I've never seen a motor come with a bigger bag of screws in my entire life. There's 1 bag, 2 bags, 3 bags, 4 bags of screws. One of them are wood screws, probably for screwing into Flite Test firewalls. That's what those are. And then the rest of them are machine screws. These are button heads. These are countersunk screws and more button heads. So they give you a lot of screws. And then the prop nut, see again, it's a self-locking prop nut. And with that hollow prop shaft, I don't know. I don't know about that. I don't know. If anyone has any long-term experience with this motor, I'd love to hear your comments about it. But I'm not feeling that, to be honest. Okay, I'm going to put this together and we'll put it on the judge. John, I'm going to tell you right now, I'm not going to Loctite this because while that's my practice, I don't know if it's yours, and you can always go back and add it, but once it's on, you can't take it off very easy. So I am not going to Loctite this for you. If you want Loctite on here, you're going to have to take it apart and do it yourself. The good news is all the screws will be set, so if you just take one screw out at a time, it'll be real easy for you. All right, I got the Flite Test Radial 2218 installed on the judge, and before I get started with the testing, one other thing I want to show you is that I actually did testing on a 2836 Turnigy 1100 kV with 3 and 4 cells, and that testing revealed 245 watts with a 9.6 and 298 watts with a 10.47 slow fly, which is where I landed with a 3 cell. So 298 watts with a 10.47 slow fly, and then I didn't, on 4 cell, I stopped at an 845 because I had 295 watts, but only 20 amps, so it probably could have gone a little higher than that. All right, so the next thing to do is spin it up and get a KV reading. Here we go. All right, 1355. I came in 1355. I've seen other tests on this motor that came in at 1180. So I'm starting to think that the KV reading on this is not very accurate. For the future, I'm just going to go with the rated KV because I just don't, at this point, I don't think this equipment is giving a very accurate KV reading. So I see 1355, but I'm going to go with 1180 for my measurements going forward. All right. Let's get a prop on this thing and spin it up. I'm just going to go right after it with the 10.47 slow fly. All right, we're ready to put this thing to the test. I'm running a 3S battery with an APC 10x47 prop. When I run it, I'm looking for thrust and RPM. I'll gather the rest of the numbers after the prop test is done. Here we go. All right, on that test I saw a little over 1,500 grams of thrust. I saw 9,536 RPM, and on the amperage, 3165. The volt sag, 1136. The watts, 364.9. We'll call it 365. So that is the 10x47. That's the prop they recommend on this motor. And after that run, it's hot. That's hot. I mean, I can hold my hand on there, but it's hot. I'm not surprised by this. 31 amps, and that motor's hot. I don't have a temperature gun. I wish I did, but I don't. But that definitely felt hot, and that was not a very long run. So 31 amps. All right, let's take this off. I'm not running that on a 4 cell. You know, in the opening I said I was going to beat the devil out of this motor. I'm not. It's not my motor. I'm not going to treat it badly, but I'm not running a 10.47 slow fly on a 4 cell on that battery, on that motor. Sorry. Ain't going to do it. All right, this is a 10.6 master air screw, and I'm curious about this because when I did the Sunny Sky testing, what I noticed was that these were very efficient props. I'm more and more interested in how these things perform. But if they say it can run a 10.47 slow fly, it should be able to handle a 10.6 electric. If I see anything north of about 31 amps, I'm going to kill it. So here we go with the master air screw 10x6. All right, on the master air screw, I got 32 amps. Volt sag was 1166. The wattage 379. And temperature is too hot for my taste. All right, so that proves my point, guys. I think 31 amps to me, I personally, I wouldn't run this at 31 amps. It's too hot. It's too hot. They say the 1047 slow fly. I don't like it. I personally wouldn't do it. I would really love to hear if anybody's got any long-term experience with this thing running a 10.6 or a 10.47 slow fly. Very curious about that. As far as the rest of the numbers go, 32 amps, 379 watts, 1458 grams of thrust. And to me, too hot. I wouldn't run that. If that were my motor, I wouldn't do that. So let's see what else we have here. Let's try a 947. I have a feeling I'm going to catch some flack for this, to be honest with you. I really do. I have a feeling I'm going to catch flack for this video. But you know what? I don't care, because I think when you're going to sell things like motors, brushless motors, you can't hide. You got to tell us. You got to tell us. You got to tell us what the numbers are. It's one of the reasons I'm such a strong advocate for Cobra. It's because they publish real life data and their specs match up with their motors. And their data is accurate, man. It's accurate to a fault. I have a lot of respect for that. In other words, we are running a 9x47 slow fly this time. And I have a topped off 3-cell battery. So here we go. I just got to listen for vibrations. Nothing, that's good. All right, I'm going to punch it. Here we go. Okay, I saw 1,092 grams of thrust, 237 watts, 19.57 amps, and the volt sag 11.8. That's too low. That's too low. That's not enough. But that motor feels good. That motor does not feel hot now. So I think we got to find something between the 10.6 and the 9.47 slow fly. So I'm thinking like 10.5 maybe. How about that? No. This time I've got an APC 10x5 running a 3-cell battery. I'm going to spool it up and look for thrust and RPM. We'll get the rest of it after it spools down. Okay, on the thrust I saw 1315 at 11,019 RPM. So, and the motor is cool. Now let's check the amps. 27.79, the wattage 333, and the volt sag 1197. Now we're talking. That's your prop right there. That's what I would use. I think the 10.6 is too hot for this. I could tell by touching it, it's too hot. I think the 10.47 felt too hot to me. I mean, you're punishing it. Maybe if you live in a cooler climate, you can get away with that. 10.5 though, the motor comes off cool. We're making 27 amps. We're drawing 27 amps. We're making 1,300 grams of thrust. I mean, that's gonna feel really good. So I'd say 10.5. I like that combination on this motor quite a bit. I want to see the efficiency numbers, of course, when we're done, but I like that combo. Okay, that's it on the 3S testing. I'm done with that. We're done with 3S. Now let's take a look at 4S. And since I landed on a 10.5, again, I want to look at efficiency, but I think 10.5 is the right prop on 3S for this guy. So now let's take a look at 4S, and I'm going to say if that was a 10.5, I'm going to be curious about like a 9.5 or a 9.6. Well, It's almost like I knew what I was doing. I got a 10.5, a 9.5 and a 9.6 right there. Okay, we'll try the 9.5 first. And got a brand new 4S battery ready to go. Okay. Make sure I don't have any crazy vibrations. A little bit of a vibe there, but not bad. All right, I'm gonna run it. That's 36 amps. 36.28 amps with 579 watts. That's interesting. 579 and 1563 on the sag. 1739 on the thrust. 13,417 on the RPM. And it's too hot. It's too hot. This doesn't surprise me, guys. So man, I can't. I just got to call a spade here. Do not run a 10.47 slow fly and a 4S on this motor, okay? Just don't do it. That'd be a bad call. Bad call. And I'm a little annoyed that there's material out there that suggests that that's okay to do, because it's not. That's not okay. There's not a chance in hell that I would run a 10.47 slow fly on a 4-cell on that motor. It would kill it. And if it didn't kill it, it'd probably burn a hole through your airplane. It's not okay. That's not okay. I'm disappointed in that. You know what? I'm done. I'm done messing with this, because here's the deal. I knew before I started what a 2836 motor was capable of doing, and all this did was prove the point. There's nothing magical about this motor. There's nothing super spectacular about it. It's a 2836 1100. Let's take a look at some numbers. All right, guys, just like I normally do, I will put up a graphic on the screen so you don't have to look at my chicken scratching. But I'm gonna, here are some notes. 10 by 4.7 at 4S, no. That's horse hockey is what that is. Don't do it. If you want to run a slow fly prop, take a look at a 947 on 3-cell. That'll give you 1,092 grams of thrust for a very efficient 4.6 to 1 on the thrust to watt ratio, and you'll probably have a lot of fun flying that plane. Just make sure your watts per pound makes you happy, okay? But as far as the right prop for this motor goes, in my mind, there is no question that the 10 by 5 electric is the right answer, because it puts the amperage where it needs to be, about 27, 28 amps. We'll call it 27.79 amps. We have a thrust to watt ratio of 3.94 to 1, which is respectable. That's a respectable number. The motor did not come off hot, and the cost per watt, it's a little high. On this motor, that's a little high. We can do better. I've seen more efficient motors in terms of price than 9 cents per watt. A 9.5 on 4, I don't think this is a good 4S motor. I think there's a little too much going on here to run this at 4S. A little too fast for that. I just saw crazy numbers. 579 watts out of a 76 gram motor is too much. 36 amps is too much. If you wanted to run 4-cell, you're looking at probably an 8.4. I'd say I would have tried an 8.4, or this was a 10.5. I would have tried an 8.4, maybe an 8.6. A 9.5 was too much. So maybe an 8.6, probably an 8.4, 8.5. That's it. So there you go. That's what I think about the Flite Test 2218 1180 kV radial. I really wish they would put an amp limit because without knowing that, you don't know. You have to put amp limits. Got to put amp limits on your specs. It's annoying that they don't put amp limits on their specs. You have to do that, because if you don't know what you're doing with amperage, you're going to fry the motor. The motor's going to come apart and your plane's going to crash. Amperage is important to understand with these motors. I could care less about voltage. I mean, voltage figures into the equation, but you got to know where the amps are. And you can tune voltage after that, because you can either go 3-cell, 4-cell, 5-cell, you can adjust the props, but you have to know what your amp limits are, because that's what's going to cause the damage. All right, so at the end, this Flite Test Radial motor, I don't know. It's okay. I don't think anything really stood out to me. I can tell you, looking at the Leopard specs, the 2835, 71 grams, 5 grams lighter, and their max current is 28 amps, that's going to deliver the same power. But I also think it's the same price. The Cobra, I'd be willing to take a look at that. So it's okay. You know, I guess it's okay. There's no surprises with this motor. It fits in its weight class pretty well. Okay, before I close this out, I just wanted to take a look at how this motor stacks up against the Cobra, because the Cobra is a good benchmark. And they put the 10.5 and 10.6 in yellow at 234 amps and 246 amps and, sorry, 234 watts and 246 watts. So this motor was making more power than that. What is the thrust? Thrust, 1166 on the 10.5. Okay, so there's something to look at right there. And we've already kind of covered this too. So in my emotion, being upset about them not listing the amperage limits, I broke my pen. Okay, so the equivalent Cobra made 1166 grams of thrust on a 10x5, and this motor made 1315. So 1315 against the Cobra at 1166. That's an impressive number. So 1315 minus 1166. So that is 149 additional grams divided by 1166. That's 12%. Oops. So 12%, let's see, 1166 times 0.12 plus 1166. Yeah, close enough for government work. Okay, so what?
I didn't get that.
Shut up! Siri, go away. Okay, the Flite Test motor, 1315 grams of thrust on a 10.5. The Cobra makes 1166 grams of thrust on the 10.5, same voltage. So that gives the Flite Test motor 149 gram improvement, so about 12%. So about 12% stronger than Cobra. And price-wise, let's take a look. $31 against the Flite Test Radial at 30 bucks. So they're within $1 and within 10% on the thrust. I'd say that's a good showing for the Flite Test on that front. Let me see the wattage real quick on this. Wattage on the 10.5, 11, 234 against, well, you know what? I got to do the efficiency. You can't just do the wattage. So I got to do the efficiency. The 10.5 was 1166 divided by 234. So 1166 divided by 234. Oh, yeah. 4.98 to 1. So, okay, so there you go. There's the give, right? That 1350 grams of thrust is 12% more than the Cobra makes, but the Cobra's efficiency, 4.98 to 1. So you say, well, what does that mean, John? It means you fly longer. For this, everything else being equal, you fly longer. It's more efficient. So it's easier on your electric consumption is what that means. So you got a more efficient outcome on the Cobra and a 12% more power on the Flite Test Radial. So now you have to ask your question, what's more important to you? Do you want the extra 100 and 49 grams of thrust, or would you rather have a motor that's a full point higher on thrust to watts when it comes to efficiency? You're the only one that can answer that question. I can't answer it. All right, guys, there you go. There is the prop testing on the Flite Test 2218 1180 kV. I hope you enjoyed the content. If you did, your subscription would definitely be appreciated. And for you folks that have been around for a while, keep the comments coming, keep the thumbs up coming, and keep telling your friends, bring them along. Let's get people involved in participating in the channel. I appreciate all the interaction that you all provide. Thank you very much. Have a great night.